about a project titled Twitter Sentiment Analysis based on Ordinal Regression. So now coming to the introduction part, the integration of ordinal regression not only enhances the accuracy of sentiment prediction but also enriches our comprehension of the intricate emotional tapestry woven into the vast Twitterverse. Through empirical validation and comparative analysis, this study seeks to establish the significance of ordinal regression as a potent tool for Twitter sentiment analysis, thus fostering more insightful interpretations of public sentiment. By adopting ordinal regression, this study aims to harness the inherent order of sentiments expressed in tweets, offering a more sophisticated analysis that captures the sentiment gradient more accurately. The proposed research delves into the development and application of an ordinal regression-based Twitter sentiment analysis system. So now coming to the objective part for this project is to validating the effectiveness of the ordinal regression-based sentiment analysis system and conducting through comparisons with traditional methods. This research aims to demonstrate the superior performance of the proposed approach. Ultimately, the research aspires to establish the significance of ordinal regression in enhancing sentiment analysis accuracy, offering a stepping stone towards more refined and insightful analysis of sentiment dynamics within the dynamic realm of social media conversation. User conclusion of Twitter sentiment analysis based on ordinal regression is that this research underscores the value of adopting ordinal regression techniques in the realm of Twitter analysis, ushering in a new era of more accurate and nuanced sentiment classification. So now coming to the requirements part, we have two types of requirements, that are hardware requirement and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, here first we have load NLTK dataset. In this initial step, a dataset from the natural language toolkit, that is NLTK, is loaded. NLTK is a comprehensive library in Python designed for natural language processing tasks. The dataset could be a collection of labeled tweets with sentiment annotations. Second, read NLTK tweets data. Once the NLTK dataset is loaded, the data within it needs to be read and processed. This includes extracting features from the text data such as tokenizing the tweets, handling punctuations, and potentially applying text normalization techniques like stemming or lemmatization. Third, run SVR algorithm. Support vector regression, that is SVR, is a machine learning algorithm used for regression tasks. In this context, it is applied to predict sentiment scores or values associated with NLTK tweets. Fourth, run random forest algorithm. The random forest algorithm is a popular ensemble learning method that combines multiple decision trees to make predictions. In this step, the random forest algorithm is employed to classify tweets into different sentiment categories based on features extracted from the text. Fifth, run decision tree algorithm. The decision tree algorithm is a fundamental machine learning method used for classification and regression tasks. In this context, decision trees are used to classify the tweets into different sentiment types. The algorithm splits the data based on features to create a tree-like structure of decision nodes that ultimately lead to classify the tweets into their respective sentiment categories. Sixth, detect sentiment type. After running the algorithms, that is SVR, random forest, and decision tree, the sentiment of each tweet is detected or predicted. The sentiment could be classified into multiple categories such as positive, negative, or neutral, or it could involve sentiment scores or values indicating the strength of the sentiment expressed in the tweet. Seventh, accuracy graph. To assess the performance of the employed algorithms, an accuracy graph is generated. This graph illustrates the accuracy achieved by each algorithm in predicting sentiment or sentiment scores in the NLTK tweets. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing some dataset over here. Negative tweets, positive tweets, train and test and tweets over here. And another folder named as test. In this we are containing a dataset over here for testing. And here this is the main Python file which just contains the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on load NLTK dataset button to load Twits dataset from NLTK library. So now here on this screen we can see total 10,000 Twits are there in NLTK library. And now click on read NLTK Twits dataset button to read all Twits to build TF-IDF vector. Upon each button click, you need to wait for some seconds to get the output over here. So here on this screen we can see total 8,000 Twits used for training purpose and 2,000 Twits used for testing purpose. And now click on run SVR algorithm button to train model on that dataset and to calculate its accuracy. So here we can see SVR generated over here 0.71 prediction accuracy. And now click on run random forest algorithm button to calculate its accuracy. So here on this screen random forest got 0.88% accuracy. And now click on run decision tree algorithm button to calculate its accuracy over here. So here on this screen decision tree got 0.91% accuracy. And now click on detect sentiment type button and upload test tweets to predict its sentiment. In test folder inside test.txt, you can see there is no sentiment label and applications will detect it. So now click on open button over here. So here on this screen, uploading test tweets files and prediction results over here. For each tweet we can see the classified or predicted sentiments. And now click on accuracy graph button to get the graph. So here in this graph, x-axis represents algorithm name and y-axis represents accuracy. From this graph we can see decision tree got better prediction compared to other algorithms. So now using another algorithm called softmax, but it's not a classifier algorithm, so I'm not implementing it here in this project. So now coming back to the conclusion part. As social media continues to evolve as a central platform for communication and expression, the significance of refined sentiment analysis methodologies become increasingly evident. Through empirical validation and meticulous comparative analysis, this research firmly establishes the efficacy of ordinal regression in the realm of Twitter sentiment analysis. Furthermore, this research presents a noteworthy contribution to the broader fields of natural language processing and sentiment analysis methodologies. The successful integration of ordinal regression serves as a foundation for future advancements in sentiment analysis across various textual datasets, transcending the boundaries of social media platforms.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.